First of all, I want to make sure I thank all the organizers and Ravi, obviously, but the whole organizing crew out here. You all have been absolutely fantastic at being able to put together this event with lots of really interesting talks. And so I'm really grateful for all the effort that you put in to do this. What I'm going to talk about today, so one of the things that we continue to debate as we listen to these conversations and listen to these presentations is, where in this is the web science part? And I think that we're going to continue to have this conversation certainly today and going forward as we look at what we are doing, etc. So I mention that up front because I want to inoculate against anyone who might look at any one of these presentations yesterday or today, with the exception of, say, Wendy's presentation, and say, well, is this really web science or is this web but not web science, and so on and so forth. And that's certainly something that could be leveled against what I'm going to talk about today. So with that said, what I'm going to talk about today is really an interest that has been somewhat recently an interest that has emerged in the area of trying to figure out how big data and how the way we work on the web is changing the future of work. And one of the topics that gets discussed a lot in this context is the term people analytics, even though the title that I put here is Relational Analytics, and you'll see in a minute why I use that title. But one of the things that people talk a lot about is people analytics. And it really was in large part sort of pushed forward by people who were looking at data science and saying, can't we apply this to people? And one of the areas that it was one of the late adopters of data science, if you may, was the HR department. So this was an article that appeared in Forbes in 2015 and said, the geeks arrive in HR, people analytics is here. An article that was a couple of years earlier, how Google is using people analytics to completely reinvent HR. This was the sticker that people at Google in their people analytics group at Google, this is the sticker that they would put on their laptop computers in order to say that for the first time now HR is not your grandfather's HR, it's now all data driven because you have all this data that you can take a look at. And in fact, the New York Times had a story that said what Google learned from its quest to build a perfect team that was based on Google spending 2 years studying 180 teams and identifying the most successful traits that showed up in this. And I think that's important because the 5 traits that they showed up on it was to say that the teams that were successful, the number one issue was psychological safety. And then dependability, structure, meaning, and impact. What is missing is technical skills. And you would think that that would be a very important part of the success of a team. And they will criticize that, well, this is Google, where everyone had good technical skills, so you really didn't need, that was not much variance on that particular front. That may be the case, but the important one I want to point out is psychological safety means that people have the ability, there was a culture in the team where they could admit to failure, they were not shamed, there was no finger pointing, and so those kinds of issues were in place, etc. But one of the things you also notice is that these are all attributes of the individuals. And I'm going to come back to that in a minute. So this was a report that came out, again, from McKinsey in 2015, saying power to the new people analytics. In 2017, this was a report that was from Deloitte that also was talking about 2017 global human capital trends. And one of the interesting things in this report was that Deloitte said that only 9% of the companies believe that they have a good understanding of which talent dimensions drive performance in their organization. So this is a classic example of the kind of hype that we talked about, that Wendy talked about, the hype in terms of having the hype associated with AI and how it goes into the winter of discontent and so on and so forth. And here is something which everyone now says is really the future, and yet only 9% of the companies even believe that they have a good understanding of what drives it, etc. Another report that was done actually by Tata Consulting Services also talked about HR analytics, and actually tongue-in-cheek said no longer just a buzzword, but a part of what they found was that a survey that they had conducted found that just 5% of big data investments go to HR, the group that typically manages people analytics. So even though organizations are investing a lot in data science and in those kinds of issues, a very small amount of the data science investment is actually going to understand people or the social aspects of these issues. And so one of the things that we wanted to talk about in this case is my collaborator, Paul Leonardi, who is who used to be with me at Northwestern, now it's the University of California, Santa Barbara. He and I published this article in November in Harvard Business Review, and we titled the article, Better People Analytics, Measure Who They Know, Not Just Who They Are. And this speaks to the issue that I was mentioning to you, that past people analytics typically focuses only on things like individual trait data, personality characteristics, individual state data, things like psychological safety, how safe we feel in order to do these kinds of issues, and then a combination of people's personality and how their feelings. But it's all based at the individual level. What we argue is that a lot of this can be gained by combining people analytics or the attribute analytics with what we call relational analytics. That is to look at people's network data as individuals, as teams, as organizations, and so on and so forth. So we're basically making a case for why we want to move from people attribute analytics to relational analytics. Now, why now? Well, one of the things that's happened is that for a long time, people have actually been studying networks. There's a lot of research that shows evidence of how networks actually explain a lot more about what happens in organizations than individual level data or attributes of the people. But the problem always has been, the big sort of bottleneck is that collecting network data through surveys is an inordinately tough thing. Imagine having a roster where you're asking people who they connect with, etc. And so one of the big changes that's happening, the why now part of it, is because of this. We now have an our workplace now has been completely immersed with a lot of what is sometimes referred to as enterprise social media. So as much as social media is like Twitter and Facebook that we use in our social life, in the workplace we now have a lot of different tools that falls into the category of things like enterprise ESM or enterprise social media. I'm assuming some of you have used some of these packages like Slack or Trello and so on and so forth. And so or Salesforce and having Chatter was one of the early ones in this area actually. And so part of what that does is it actually gives us some collateral information that while it's great because it helps us to collaborate with one another and share messages and at-mention people, etc., one of the things that it also does is it leaves a digital trace or a digital exhaust. And that digital trace or digital exhaust can now be used to be able to look at patterns or signatures about what is happening in a way that we believe, and this is still a theory to be tested, we believe that this information can in fact be analyzed in a way that allows us to be able to predict what people would have said on a network survey without having to actually have them complete a network survey. And that's at the heart of an interesting hypothesis that we have about how we might be able to move from where we are and be able to leverage the strengths of what network analysis can offer us without necessarily having to force people to answer network surveys. So this is an example of an inspiration that we get from people who have been looking at fMRIs and seeing what is happening and begin to look at certain patterns and look at those as signatures. This is a more artistic one where if you've looked at this particular image, you'll see that as you begin to zoom out, that's when you begin to see a picture. So when the entire idea of pointillist approaches is that when you're zoomed in too much, you don't see something. You need to zoom out, and it's at that point that you're going to begin to see images. And so that's why I like to think about a lot of this, what is happening with networks, as it's not a microscope, but it's a macroscope, because you can only see it when you zoom out to a certain level and begin to see certain patterns. So what are these patterns that you can see? If you look at the activity networks that are generated by employees, you have all these different kinds of approaches that they use. They have like buttons, they have messages they send people, they send text messages, they give badges to people. These are all kinds of things, and it's very nice that we have these data. The challenge is, how do we take these kinds of data and then from that figure out whether individual employee A trusts employee B? And so part of what we've been doing a lot of work is to see the ways in which we can take metadata of this kind, and potentially even the text that's associated with it, though there are large privacy issues associated with that, but take the metadata and see if we can infer trust networks, advice networks within organizations. Because if we can, then we know that there's a lot of things we can learn about organizations from that approach. So we call these as different structural signatures, and in the article that we published in Harvard Business Review, we identify 6 signatures of relational analytics, 2 at the individual level, 2 at the group level, and 2 at the company level. So at the individual level, we identify a signature, for example, that will say, how likely is it that employee X is likely to come up with good ideas? And it turns out that signature is associated with the fact that if employee X is talking to 3 people who don't talk to each other, then she has a much greater likelihood of coming up with a new idea as compared to somebody who talks to people who know each other. Same thing can be said for influence. In fact, the influence algorithm, the signature for influence, is very similar to the PageRank idea, which says that I'm going to have a high PageRank in Google, not because a lot of people link to me, though that's often how it's described, but what it's really doing is it's saying a lot of people link to me, who in turn are linked to by a lot of people, who in turn are linked to by a lot of people. So it's a recursive definition which gives you the sort of eigenvector representation of why that particular link is at the top. So the influential person is not necessarily somebody who has just a lot of links, but links from influential people who in turn are linked to from influential people and so on. So I'm not going to go through all of these, but this is a summary table where we actually, in the magazine, in the article, we lay out the structural signatures for ideation, for influence, for the efficiency of a team, for the innovativeness of a team, the extent to which a team is siloed, and the extent to which a team is vulnerable. And we were rather pleased with this. I can tell you that I've written a few things in my life. I've never had as much activity on LinkedIn as resulted from this one article in HBR that just everyone was trying to reach out to do all kinds of, come and do research with us. We'd be happy to share our data, which for people like us who study this is quite the bonanza, etc. But very soon I realized, and Paul and I talked about this, is that this particular representation is still looking at it as a solution that is looking for a problem. We are saying that these signatures exist, but if you look at organizations, they're like, what pain point is this going to solve? And so we are now working on a follow-up article for HBR, and so I'm going to share some of those ideas with you here and talk about it, where we, instead of looking at the signatures from the other end, we're now saying, what are the problems that these things can solve? What specific problems that this can solve? I will say that in conversations that I've had now with both platform developers like IBM Connections, Facebook at Work, both of which reached out to us to talk about this work, but also large companies that are interested in doing this, companies like Siemens, for example. One of the things that surprised me is that they immediately see a benefit of using these approaches to better understand diversity in organizations. And it's not one of the 5 that I put here, but that's one of the reasons I want to talk about it, because that is something that is, even though the 5 that I have here are examples of what I'm going to talk about from work we've done, one of the new areas that we have not done as much work on, but there are lots of people in industry who see a potential application is in this area of diversity. And most of it is saying that organizations are looking desperately for finding ways in which we can improve diversity. Wendy had her slides yesterday that the field of AI or computer science, etc., is too important to be left to men. But one of the things that the argument that has been extended is that even if you begin to change the composition and the demographics of what happens within organizations, you might achieve what superficially looks like having higher diversity, but what you're missing out in is having higher inclusion. And the difference between diversity and inclusion is that you can have a diverse group and still find that the 3 women in the group are never engaged upon with anyone else. And so part of what networks allow you to do is to not just see who's sitting around the table, but who's talking to whom, who's responding to whom, whose arguments are being taken seriously, etc. So the idea of moving from diversity to inclusion is something that I was very pleasantly surprised to see that it resonated with a lot of people. I don't have an example of that here, not because it's not important, but because the research that we've done so far has not specifically looked at that. And what I want to do is talk about some of the work we've done and how it relates to some of these issues. So the first one I'm going to talk about is team self-assembly as opposed to team staffing. And then I'll talk about predicting team performance in terms of competitions, how you can use it to predict succession planning in companies, and then how you can also anticipate inter-team conflict. These are all pain points that organizations have mentioned to us are important things that if there are ways in which relational analytics can anticipate these and head these off, then it'll be really helpful. So we all know that we are in self-designing teams. People have agency and are responsible for finding and selecting other members, and especially in academia, but also now increasingly in the future of work, you find that people are self-assembling into teams on the fly. There is this idea of what are called flash teams and flash organizations, where you stand up a team, you even stand up an organization in the span of, say, 3 hours, believe it or not, and that organization may only exist for another 7 hours, and then it would disappear. So these are called flash organizations, flash teams. Michael Bernstein and Melissa Valentine, who are at Stanford in computer science and in management science and engineering, have really been pushing the boundaries of these kinds of issues. However, we also know that sometimes things go really well, but then sometimes they don't go so well. This would be a dream team approach, and this would be a nightmare team approach. And so part of what we were trying to do is to understand how do people go about self-designing your teams. And you can ask yourself that question as you think about the ways in which you form teams, either to work on research projects or to work on class projects and so on and so forth. So here I'm going to talk about work that I've done with some people in my lab, Marlon Twyman, who just accepted a position at the Annenberg School for Communication at University of Southern California. Diego, my collaborator, Leslie DeChurch, who's on the faculty at Northwestern, and a former student, Jackie Young, who's now doing a postdoc at Harvard Business School. And one of the things we did was ask a very simple question. How do people decide who to invite to their team in the modern organizational landscape? How does one make those kinds of decisions? And one of the things, obviously, is that this is an example of where the web has really changed the ways in which we understand who we may want to have on a team and who we might want to invite on a team, etc. And so imagine a situation where you want to study, and so the results I want to talk about is teams that were set up to study innovation. They were supposed to come up with innovative ideas. And these were classes, but there were two classes, one in ecology, one in social psychology from two different universities. And they were asked to come into project teams, and each team was required to have members, of course, from both of these universities. And the goal was to simulate an advertising campaign to mitigate an environmental sustainability issue. So that was the idea that they were asked to come up with, etc. They were put into teams, and for doing this, they used a web-based platform. And I'm going to talk a little bit about that web-based platform in a minute. But just to give you an idea, so we did it in 2 consecutive years. The first year, there were 200 participants that assembled into 32 teams using the web, and then the second was 197 participants who assembled into 31 teams. The platform that we use to do this is something that is called the My3Team Platform. In fact, one of the developers of the platform, Anoop, is sitting right there, because he's working now with our collaboration at IIT Madras. And the idea behind this platform is, how many of you are familiar with Tinder or Match.com? Some of you have heard of that? Yeah? Some of you are too shy to admit to it? Yeah. It's basically the same idea, that if we can have these kinds of technologies for building up our, for exploring romantic partnerships, why don't we have something similar to also explore who we may want to team up with in the workplace? So very often I refer to this as the Match.com for teaming, so forming teams, etc. And the basic idea is quite simple. Just like in any of these other tools that you have, you build a user profile. You're asked to respond to personal surveys. At least for now, you have to still respond to surveys until we have good ways of algorithms to get it from digital trace data. And then after everyone has completed the survey, then you can go in there and you can state your preferences. I'm looking for somebody who has an expertise on this topic. I'm looking for a friend of a friend. I'm looking for somebody who has a similar personality to me. And all that happens is that it comes back with recommendations. So it's really there's nothing complex about the algorithm. It's simply a complex search query that goes and looks at all the data that other people have provided as part of their survey responses, and then filters it and gives it to you in terms of the rank orders it, but also tells you how well it matches with the query that you wanted to do. So this is an example of where people would be able to review the recommendations. They'll see a little bit about these people, why these people matched it, and then they can go ahead and select if they want to invite that person. And on the right-hand side, you see that invitation being sent to that person. That person gets an email saying, so-and-so is invited you to join the team, and then you can go into the platform and take a look at it. It's really quite simple. There's nothing very complicated about the technology, but it is a web-based platform that does this. So one of the things then that we can take a look at here is to say, okay, well, if we have these data, it's nice because it helps people form teams. It's even better because it allows us as researchers to understand how people go about forming teams. And one of the things that the world has never had a chance to do is to be able to get a first-hand view of that entire sausage-making process that happens before the team is formed. We all know when a team is formed and can say, oh, this team is very diverse or not very diverse, etc. But it's almost impossible for us to go rewind and say, what happened when people are trying to form teams, and especially those that never formed? And so this is a great opportunity to look into the process of how people go about looking for it. So we asked a very simple question. Who invited whom to a team? And part of it was we were trying to see what factors influenced who invited whom to be on the team. So the team made invitations. So that was what we looked at. What explains why I might invite a particular person to join my team? And there are several factors that could be taken into account. Clearly, skills is an important part of it. Homophily, such as things like there's pretty good evidence that males are more likely to invite males, females more likely to invite females, whites more likely to invite whites, and so on and so forth as part of the comfort level. There's also some evidence in the literature that prior collaboration, if I have a good experience working with someone, I might want to work with that person again. But we also have the other one where the technology should change it. If I'm giving you a list of recommendations, I rather hope that my recommendations are going to be taken seriously and impact who you want to invite. So we set up a statistical model in networks that is called exponential random graph models in order to be able to assess those particular links. And we have to use these models simply because the network data, because it's invitation network, when those observations are not, they don't meet the IID requirements independently and identically distributed, and that's why there's a whole machinery of doing network analysis to answer those questions. Well, what did we find? We find that, in fact, just as we would expect, that if your name appeared as a top 10 recommendation on the web platform, on the My3Team platform, that you are indeed much more likely to be invited. Not entirely a surprise. It means people are paying attention to the search results, essentially. The second one is that if you have previously collaborated with the recipient, you're also very likely to be invited. So you're more likely to invite somebody with whom you've had past good experiences, hopefully good experiences, because you can trust them. So the interesting one, though, was this last one, where we wanted to see to what extent will the prior collaboration interact with whether that name appears on the top 10 list. In other words, if a name of somebody who I am a previous collaborator with, if that showed up on the top 10 recommendation results, then how does that impact whether I'm more or less likely to invite that person? The short answer is that anytime there's something that shows up on a recommendation, it is going to increase the likelihood that I'm going to invite that person to be part of my team. However, that increase, the bump that you get by showing up on the recommendation, is substantially higher for somebody who you did not know previously as compared to who you did know previously. And we found this in both the samples. You see, this is in sample 1, and the same kind of result was in sample 2. What does it say? It basically says that, that recommendation, showing up high on the recommendation, is much more important if I don't have experience working with this person as a previous collaborator. But if I do have experience working, I'm saying, oh, I know this person, and this person shows up on the recommendation, I am slightly more likely to invite this person, but I'm much more likely to invite somebody who I have not previously collaborated with, but who shows up on this particular top 10 recommendation list. So this is an example, in my mind, of how we can begin to see how the web, and in this particular case, the My3Team platform, provides us two things. It provides people an opportunity to find teammates, but it provides us as researchers a microscope into seeing the processes by which people make these decisions. The result that I will not show details yet today, but I'll mention it. This is an upcoming paper in Chi, and what we found there is that people are more likely. So the question there we asked was an even more primordial question, not who you invite, but what do you search for when you're looking for someone? And it turns out, and this is the paper that's coming out at the next Chi conference, has been accepted for it, is that when people start searching for keywords, they always search for areas of expertise and skill. So I need somebody on my team who's good at, at Java or at Python, etc. Those are the things that I look for in the search. And yet, when it comes time to invite, it's exactly what we saw here. People are more likely to invite people who are their previous collaborators. And so there's a disconnect between what people are searching for initially and what are the criteria that they use later on to actually invite people to it, etc. Very quickly, I want to go to the next one. And this is a little different. So a lot of the time, we are now in today's contemporary workplace in the future, we are, in fact, assembling a lot into teams. But there are still some organizations where it's not so much of self-assembly as much as it's staffing. We have a lot of funding from, not a lot, we have some amount of funding from the Department of Defense. And they're like, I don't really care about your self-assembled teams. But when we put together platoons in the U.S. Army, we don't allow people to just go find their own teams. We tell them what teams they're going to be in. So what I'm going to talk to you about is not a DoD example, but another example that is sort of out of this world, where we are beginning to see the need to do team staffing. And this is work that I've done with a current PhD student, Brendan Anton, who's a PhD student in Industrial Engineering Management Science, Jackie Young, who I mentioned, who's now at Harvard Business, Suzanne Bell, who's a colleague at DePaul University, and with Leslie DeChurch. And this, I said that this example is out of this world because it is. It's pretty much said now that humans are going to become an interplanetary species. And the first planet that we are likely to inhabit is Mars. And this is stuff, this was from the USA Today, National Geographic Channel. NASA has made a real commitment to being able to do this. And we have to understand that there are orders of magnitude here about traveling to Mars that are quite significant. So the International Space Station, which orbits above us, is 250 miles above the Earth. The Moon is 250,000 miles, so 1,000 times farther. And then Mars is 250 million miles, which is 1,000 times farther than the Moon. And so if the Moon is a step away, Mars is 3,000 miles away. If going to the Moon is walking across the living room, going to Mars is like walking to Tibet. So you get an idea of some of the differences. The travel time today, based upon what the orbitals set up, is going to take approximately a year to get there. You have to stay there for a year till your orbital position that you can swing back to Earth. And then again, the trip back is going to be about a year. So we're talking about, a 3-year excursion that's going to happen in this particular context. And in addition, because of the laws of physics and the speed of light, the amount of time it's going to take for a signal from Earth to go to Mars can range between 3 and 22 minutes, which means that if I were to say something here, it would be 44 minutes at most by the time I get a response back. In all of this situation, one of the things that people realize is that this is going to be a group of people, 4 to 6 astronauts, different countries, and they're going to have to work as a fairly autonomous team. Because as they get farther away from Earth, they're not going to rely on mission control in Johnson Space Center or at Roscosmos in Russia or at the European Space Agency. And in fact, that was what astronaut Scott Kelly, who is the American who has spent more time in space than any other, he spent a year at the International Space Station, and one of the things he said when he came back to Earth was, he said, teamwork makes the dream work in space. So, of course, one of the questions that NASA is interested in is what happens to teamwork under extended periods of isolation and confinement. So this is the team staffing dilemma that they face. They're going to be 6 people, for example, who are going to be sent on a mission to Mars. And these 6 people are going to come from different countries, and you begin to see that the Russians, the Germans, the French, the Indian, and the Japanese have chosen who's going to be on the team from their respective countries. And now you face the conundrum, who should the American put on this that will likely work best with the other 5 people who have already been chosen? So this is an example where you're not staffing the whole team, you're staffing the one person you have a choice on, which is really all we'll have. NASA will only get to really have a say on who the American is in this. But you want to see to what extent that person matches personality-wise and in other interpersonal style with everyone else on the team. Now, of course, you'll say, well, in order to do this, whether it is staffing on Earth, the DoD or any other organization, or if it is staffing to go to Mars, how are we going to go about doing this? There's a reason why we haven't made a lot of progress in people analytics to allow us to predict what happens to a team. And the reason is we don't have a human petri dish to do this. We can't put people into a petri dish. It'd be nice if we could, right? Everyone know what a petri dish is? You observe them very closely. And so wouldn't it be nice if we had a human petri dish where we could manipulate people's isolation and sensory deprivation for hundreds of days while making them do complex and boring tasks and monitoring them 24/7 physiologically and via audio video? Some of you may have taken a psychology class where you learned a little bit about people like the prison experiments, Zimbardo's experiments, etc. Today we can't do this, right? There's no sane person is going to allow us to do this. But wait, that is exactly what we're doing. And the place we're doing it is all the people who are studying space. So NASA has something called HERA, the Human Exploration Research Analog, where they put people into exactly that little thing that you see there, this one right here. And they put people in there for 45 days at a time. And they have no connection with the outside world, and we get to observe them 24/7, and they get to answer all our questions, Many times they get surveyed to death, and then they also are equipped with all kinds of Fitbits and physiological sensors on their body. And just so you know, we are not the only ones doing this. The Chinese have a similar one, which they call the Lunar Palace. And they just had a group that came out of there that had spent 100 days in there on a potential mission to the moon. The Russians have their own, and this facility has had people who've stayed there for 500 days. So this was an international crew that stayed in this facility that looks very similar to the International Space Station for 500 days. That did not end well. The Canadian and another member of the crew had a blowout as part of a rather unfortunate episode and they had to actually discontinue it and remove that one person from it. So things don't always go as you might imagine when you put people and coop them up in a short space for a long time with no exit strategy, which is exactly what we would need to prepare for in this case. The Japanese have something called JAXA, or the isolation chamber, and they actually use this to select astronauts. And one of the things they make them do is over the course of a large duration, they make them work on preparing those little origami things. You're familiar with those little things that the paper origami? And the way in which the astronauts do it, the crew members do it, how much time they spend, how much attention they do, is a key criteria that Japan uses to select the astronaut crew, including those who've gone to the ISS, for example. There are other ones. The European Space Agency does things outside in Sardinia, the South Pole, or the Canary Islands. There are private foundations who do this. So we have a plethora of petri dishes where people are studying people in this context. Here is data from one that we studied. It's a crew of 4 in Hera, and we asked them every few days, who do you enjoy working with, and who is a hindrance to you? Who do you not work with? And what is really interesting about this is you look at these 4 astronauts, and you'll see that they all worked very well. They all liked each other a lot. They said they got along well. But this relationship was who made tasks difficult to complete, and here we see something a little different. Within the time 2, everyone is beginning to hate on this one crew member at the bottom. And that continues, and continues, and continues, and continues. And this crew member had no idea that everyone else was hating on him. So the question is, could we have predicted that would happen? That this one crew member was really not going to be getting along well? And that is, in fact, part of what we did. So I'm not going to go into the details of the social science behind how we predicted, but that's our goal here, is to see to what extent can we build computational models that will be able to predict it. So we used a lot of agent-based modeling, etc., that I'm not going to go into detail here, but we essentially created an agent-based model that began to simulate and predict who will like whom when, and who will see the other person as a hindrance over the course of it. And that's sort of at the heart of what we're beginning to do here. We didn't have a chance to do this back on Earth because we didn't have the kind of data that was necessary to do this. So if you look at this now, you begin to see that there are certain factors that are important. An important variable in psychology is self-monitoring, the extent to which you are constantly aware of how people are looking at you. And we find that in fact, those who are crew members tend to enjoy working with individuals who are high in self-monitoring, and they don't look at them as hindrances. That's why it's a negative relationship. They're less likely to be viewed as making things difficult. On the other hand, contextual things like high work schedules make crew members less likely to enjoy working with others. Not entirely a surprise, I imagine. But part of what was really amazing to us, and I think somewhat gratifying, is that when we begin to see how good our predictions are on this, we see that as we look forward and take the initial data and use our models to predict it, we get F1 scores that are in the neighborhood of about 0.46 for how well we can predict who gets along with somebody else. We don't do so well when it comes time to who makes the task difficult. You notice the F1 scores here are 0.56 and 0.37. What does this mean? It means we don't do a good job of predicting who doesn't like whom. We do a much better job of predicting who does like whom. And part of the reason that happens is because, fortunately for them, there are not a lot of people who dislike each other. So we have a very imbalanced data set where we have very few instances of people who find others a hindrance. And until and unless we have more examples of people reporting that they find other people a hindrance, our models are not going to do as good a job in being able to predict. I want to quickly go to the third one here, which is looking at predicting competition and team performance. This is again an area that we have a lot of interest in trying to see ways in which we can look at not just attribute analytics, but relational analytics in order to do that. And in this case, I'm going to talk about 5 minutes. Okay. So in this case, what I'm going to talk about is an article that we published in Nature Human Behavior that should be of interest to some people here. So Satya Mukherjee, who's the first author on this, is actually a graduate from IIT Madras. He's now, and then he did a postdoc with us at Northwestern. And in this article, he came to me when he was at Northwestern as a postdoc and said, I'm trying to get someone to work with me on seeing whether I can predict cricket teams, which cricket team will beat another cricket team. And no one understood cricket, and so by default he came to me and said, if your last name is Contractor, and he knew that even though I'm not related to Nari Contractor, Farooq Engineer is my dad's first cousin, and so he says, you must know something about cricket, will you work with me on this? And what we found was very interesting, and that is, if you look, so the idea was if you look at the statistics of the individual cricketer on Team A and then look at it on Team B, you don't do a very good job of predicting whether Team A is going to be better than Team B. But the moment you look at something a little different, and that is you look at shared success, where two people have played together in the past and have won, that team is going to be the team that has more of those shared successes between players is going to be the one that's much more likely to win. And after we did it for cricket, we did the same thing for NBA, the National Basketball Association, for EPL soccer, we did it for cricket, obviously, for baseball, NBA, and this is where the web comes in. We did it for an online game. Some of you may be familiar with this game called Dota 2, which is two teams that compete online with each other. And sure enough, we found consistently across all of these situations that if they're way above and beyond the individual statistics of the players, the relationships that they had with each other was much more important in terms of predicting what kinds of skills people would have. Okay, so in the interest of time, I'm going to go to my last example, and this one is about predicting conflict in space. So, predicting conflict happens to be in space. One of the things that organizations are always trying to look for is the extent to which people have conflict. And often conflict is represented in a situation where people are trying to understand whether they are on the same page. That's the term that is often used. In psychology, they call that team cognition or shared mental models. To what extent are we having similar views of it? If we are too similar, that's going to lead to groupthink. We won't be creative. If our views are too different, then we're going to also have a problem. So it's that sweet spot of where you want to have people who have some overlap in team cognition, but not too much or not too little. And as you can tell, I'm spending a lot of time these days studying space teams, and so I wanted to look at conflict in space. And you go, well, how can you find conflict in space? Well, you have situations where you have a crew that's up there, and they have their own mental models and how similar they are. And then they also have a mental model that they share with mission control, which is helping them with the mission, etc. So in this particular case, I'm going to end this with a case study from Skylab, which I bet you almost no one in this room knows about, because you're all too young for the most part to know about Skylab. Yeah, excepting the people who are not so young who know about Skylab. Right, thank you. So Skylab, for those who don't know, was actually the first United States space station. And it was in 1973. It was before the space shuttle. It was between the Apollo and the space shuttle. And what we wanted to do was to study what were the levels of shared cognition between these people and with mission control. So there were 3 manned missions with 3 crew members, a commander, a pilot, and a scientist pilot. Skylab 1 lasted for 28 days, and they did a bunch of things. Skylab 2 lasted for 59 days, and they did a bunch of experiments in space. And then Skylab 3 were there for 84 days. And I point you to the last one. The tension between the mission control and crew led to something called a mutiny in space. This is the first time that astronauts went on strike in space. And this was written up. You can look at the Wikipedia entry where they talk about the details about this. Harvard Business School did a case study on this. It was called The Strike in Space. And what we did was, Michael Schultz, who's a postdoc working with me at Sonic, he's just taken a faculty position at Indiana University. He went and got all the transcripts and decided that he was going to find out exactly, based on that, the 2 channels, all the air-to-ground communication, onboard voice transcription, 15,000 pages. And he looked at the text analytics, and he began to use text analytics to build a model of what each person's terms were. So you first build a mental model for each person, look at what they said, and have a bipartite network between the actors and the topics they talked about. Then use each person's bipartite network to build a shared mental model of what 2 people may have had in common. So this was a network in one person's head. This is the network between people's heads. And then you will look at the difference between crew and mission control, which is the CAPCOM, which is the one person on Earth. So these were some of the topics that were identified. I'm almost done here. And so this one, what we notice out here is that if you plot intra-crew similarity, that how much of shared cognition was in the team versus how much of it was there between the people on the Skylab and mission control, you find that Skylab 3, the one that had the mutiny, had the lowest level of intra-crew similarity and the lowest level of shared mental model with the outside as well, or at least relatively low. And in fact, if you look at it on day 15, you see that things didn't look that bad. They looked almost the same in the three cases, where the distance, the red lines is the connection between the crew and mission control, and the black lines are the connection amongst the crew members. Then you get to day 35, and you begin to see some real differences that are happening. So 11 days before the mutiny happened on day 46, we see that there's a sudden discrepancy that you only notice in Skylab 3. And so what it does is it provides us a way of predicting this team is about to get into conflict, or this team is both within itself as well as with other teams, etc. And so again, all I wanted to do here was to give you some examples of how we can take these things and make them much more actionable. We've been in the process is once you're able to do these kinds of predictions, one of the things that happens is you're able to take that now and build dashboards of the kind that would, even though we're building it for space, we think that one of the things we talk about in the Harvard Business Review article is that it is something that can be done back on Earth. It's just we've never thought about doing it because we've never had as pressing a need as we do in space. But it's still going to be something that we believe will change the way HR and people analytics and relational analytics will go. So I just want to end by thanking my funders, and we'll be happy to talk more about any of these during the day today. Anytime.